Hi, hello, welcome back to Homeschool. Wish you all Happy New Year. Here is your Radhika ma'am. Today we are going to start class 10 mathematics revision and we are going to start with an easiest chapter, that is chapter 2 from your textbooks, Polynomials. Let us recollect some basic concepts in the polynomials. Right? First we are going to see the type of polynomials. First we are going to know about the constant polynomial, and then linear polynomial, quadratic polynomial, and next cubic polynomial. Yes, constant polynomial, the polynomial having its degree is 0, then it is called as a constant polynomial. How can we write this? We can write this as p of x is equal to constant k. Let me take. And now linear polynomial, it can be written as p of x is equal to, x is a variable, right? Standard form of this is ax plus b. What is this linear polynomial? Linear polynomial highest power, that is the degree must be 1, where a cannot be equal to 0. Quadratic polynomial, the highest power or a degree must be 2. Then its standard form is p of x is equal to ax square plus bx plus c. Highest power, that is the degree is 2. Then this is the standard form for quadratic polynomial. And here also a is not equal to 0. Cubic polynomial, degree will be 3, that is ax cube plus bx square plus cx plus d, where a cannot be equal to 0. Next, we are going to find the sum and product of zeros of a quadratic polynomial. Let me write here, sum of zeros, that is alpha plus beta. Let alpha and beta be the two zeros you can assume. Then sum of zeros means alpha plus beta is equal to minus b by a, you can remember, or you can remember minus of coefficient of x by coefficient of x square. Okay, or shortcut you can remember alpha plus beta is equal to minus b by a. Next, product of zeros. Product of zeros, alpha beta is equal to c by a. Right? Coming to cubic polynomial. Cubic polynomial, I am going to write 3 here, that is alpha plus beta plus gamma. What are the 3 zeros for cubic polynomial? Let us assume alpha, beta, gamma. Then what is sum of all the 3 zeros? It will be minus b by a. Sum of the product of their pairs, that is alpha beta plus beta gamma plus gamma alpha is equal to c by a. Right? And next, product of all the 3 zeros, alpha, beta, gamma is equal to minus d by a. Those are the sum and product of zeros for a quadratic polynomial, and these are sum and product and sum of product of their pairs. You can see the formulas. And now last, if you know sum and product, how will you form the quadratic polynomial? There is another formula, that is k, where k is real, k into x square minus sum of zeros into x plus product of zeros. If you remember all these formulas, we are going to start the chapter. So in this chapter, we are going to have only 2 exercises. Exercise 2.1 is already there on your board. You have only one main and there are 6 graphs given here. Let's see the main heading. The graphs of y is equal to p of x are given in the figure below. For some polynomials p of x, find the number of zeros of polynomial of x, that is p of x, in each case. So, Observe the graphs carefully. What we are going to find in this exercise? We are going to find the number of zeros. Observe x-axis, y-axis. So, on x-axis, at how many points the other lines or curves are intersecting the x-axis is your question. Observe the first one. On x-axis, this line is here, means it is not at all intersecting x-axis at any point. Therefore, what we are going to say? How many zeros are there? There are no zeros. So, write that only. No zeros. Right? Second one. Observe x-axis carefully. At how many places other curves are intersecting? So, here at one point they are intersecting. So, that means 1, 0. Third one, on x-axis. See how many places they are intersecting? 1, 2, 3. How many zeros are present here? 3 zeros. And here, on x-axis, 1, 2. How many zeros? 2 zeros. Come on, start counting here. On x-axis, only observe only x-axis. On x-axis, intersecting point 1, 2, 3, 4. Therefore, 4 zeros. See the last one here. 1, 2, 3. Therefore, there are 3 zeros. So, all 6 problems within 1 minute you are going to complete. Let's start with the exercise 2.2. In this exercise, we have only 2 mains. First main, find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficient. What we are going to find here? First, we are going to find the zeros. By factorization method, we are going to find zeros. Let us assume the zeros as alpha and beta and then verify their sum and product with the coefficients. First problem, x square minus 2x minus 8. Let us first find the zeros of the given polynomial. We know by factorization method we can find zeros. X square minus 2x minus 8. Observe what number you have, 1, and here it is minus 8. 1 into minus 8, it will be minus 8. Find the factors for minus 8. In such a way, if you add or subtract, you should get minus 2x. So minus 8, what are the factors? 4 2s are 8. Minus 2 I should get. That means minus 4 plus 2 will get minus 2. So write it here. In place of minus 2x, write minus 4x plus 2x minus 8. Among these two, x is common, x minus 4. And among these two, 2 is common, again x minus 4. Now x minus 4 is common, take out x minus 4 into x plus 2. In order to get 0, so we need to equate with 0 here. That is x minus 4 equal to 0 or x plus 2 equal to 0. That is x is equal to 4 and x is equal to minus 2. The two zeros for the given quadratic polynomial are 4 and minus 2. Right? So, let us assume first 0 as alpha and second 0 as beta. Okay? Let us assume, we are assuming the two zeros as alpha, beta. So, zeros we got, we need to verify with the relation with zeros and coefficient. First, rewrite the given polynomial x square minus 2x minus 8. Compare with the standard form of the polynomial ax square plus bx plus c. Compare a is equal to 1, b is equal to minus 2, c is equal to minus 8. We know sum and product of zeros, right? So, write that sum of zeros alpha plus beta is equal to minus b by a. Substitute all these values. Alpha value is 4. And beta value is minus 2. Minus b value is minus of minus 2 by 1. 4 plus into minus, minus. 4 minus 2 equal to minus into minus plus 2. 4 minus 2, 2 equal to 2. Yes, sum of the zeros is verified. Now coming to product of zeros, that is alpha beta is equal to C by A. Whereas alpha value is 4 into beta value is minus 2 and C value is minus 8 by A value is 1. Plus in minus minus 4 2s are 8. Minus 8 equal to minus 8. Hence it is verified. Same method we are going to continue the next problem. Observe the number what you have 4 and 1. 4 ones are 4, right? Take the factors in such a way you should get minus 4. 4 factors, 2 2s are 4. Add or subtract you should get this one. Multiply you should get this one. So now minus 4 how can I get? Let me take here minus 2 becomes minus 4. If you multiply minus into minus plus 2 2s are 4. Now 4s square minus 2s plus 1. Among these two 2s is common, take out. 2s is left here minus 1. Among these two nothing is common, that means 1 we need to take out. 2s, when I am taking negative sign common, this plus becomes minus 1. Again 2s minus 1 is common. 2 times you are going to get same value, 2s minus 1 into 2s minus 1. In order to get 0, equate to 0 here, or 2s minus 1 equal to 0. 2s is equal to 1, s is equal to 1 by 2. Same manner you are going to get here also, s is equal to 1 by 2 or s is equal to 1 by 2. So let me assume this as alpha 1 by 2, beta 1 by 2. Now we need to do verification, right? So verification, first rewrite the equation 4s square minus 4s plus 1. Compare with standard form, ax square plus bx plus c. A is equal to 4, b is equal to minus 4, c is equal to 1. Now sum of the zeros, product of the 0 with their coefficients we are going to compare. That is alpha plus beta is equal to minus b by a. Alpha value is 1 by 2 plus 1 by 2 and b value is minus 4, minus of minus 4 by 4. If you do LCM you are going to get 2 by 2 and here it is 4 by 4. Minus in minus plus 4 by 4. 4 ones are 2 ones are. So 1 equal to 1, it is verified. Now coming to product. Alpha beta is equal to C by A. So alpha value is 1 by 2, beta value 1 by 2, C value is 1, A value is 4. If you multiply 1 by 4 equal to 1 by 4. Okay, so it is verified. Let's see the third problem. 6x square minus 3 minus 7x. Observe, is it in a standard form? No. If no, we need to rewrite in standard form and then solve the problem. 6x square. Next, minus 7x minus 3. See here, x power 2, x power 1, x power 0. In this order, we need to write the polynomial. Now start. What the number you have? 6 into minus 3. That is minus 18. Minus 18. Find the factors in such a way you need to get minus 7. So what are the factors? 6 3s are 18. 6 plus 3 or 6 minus 3 we are not going to get. Then what are the other factors? 9 2s are 18. I should get here minus 7. That means minus 9 plus 2. Right? If you multiply, you are going to get minus 18. Add or subtract, you are going to get minus 7. Now, in place of this, you write these two. 6x square minus 9x plus 2x minus 3. In these two, 3x is common. Take out 3x. 3 2s are 6. 1x taken out means 1x will be inside. Minus 3 3s are 9. Already x outside there. So again among these two nothing is common. So let me write it as 1. 1 into 2x minus 3. Now 2x minus 3 is common. And this side 3x plus 1. In order to get 0, equate to 0 here. Right? Now 2x is equal to 3, x is equal to 3 by 2. And here 3x is equal to plus 1 if it goes other side, minus 1. X equal to minus 1 by 3. Right? Now the zeros, we are going to assume it as alpha 3 by 2, beta minus 1 by 3. Take the polynomial again, 6x square minus 7x minus 3, and then compare with the standard form, x square plus bx plus c. A is equal to 6, b is equal to minus 7, c is equal to minus 3. Now, sum of zeros, alpha plus beta is equal to minus b by a. And product of zeros, alpha beta is equal to c by a. Alpha 3 by 2, beta minus 1 by 3 is equal to minus of minus 7 by 6. 3 by 2 plus into minus, minus 1 by 3 is equal to 7 by 6. Do LCM here, 3 and 2 is 6. Then here 2 you have 3 multiply, 3 3s are 9 minus. So 3 2s are 6, multiply here 2. 9 minus 2, that is none other than 7 by 6 is equal to 7 by 6. Both are equal. Now here product of zeros, alpha beta equal to c by a. Alpha value is 3 by 2 into beta value is minus 1 by 3. C value is minus 3, a value is 6. 3 3 cancel and here 3 1s, 3 2s. Finally you are left with minus 1 by 2 equal to minus 1 by 2. Is this clear? Hence it is verified. Fourth problem, 4u square plus 8u. So observe here, among these two, 4u is common, take out 4u, 1u is left inside, plus 2. Okay, so directly you can equate to 0 and get the zeros here. U plus 2 equal to 0 and u is equal to 0, u is equal to minus 2. Then alpha is 0, beta is equal to minus 2. Again verify the relation, means take the polynomial again, 4u square plus 8u. Compare with standard form, ax square plus bx plus c. Right? So a value is 4, b value is 8, c value 0. Sum of the zeros, alpha plus beta is equal to minus b by a. That is, alpha value is 0 plus beta value is minus 2 minus b value is 8, a value is 4. So plus into minus, minus 2 equal to 4 2s, minus 2 equal to minus 2. Coming to product of zeros, alpha beta equal to c by a. Alpha 0 into beta minus 2 equal to c value is 0, a value is 4. Right? So 0 into anything 0, 0, 0. 0 equal to 0. Fifth one, t square minus 15. Directly we can equate it to 0 to get zeros. T square is equal to 15. T is equal to square root of plus or minus square root of 15. That is, one is plus root 15 and another 0 is minus root 15. So let us assume it with alpha plus root 15, beta minus root 15. Okay, now let's start the verification. First again take the polynomial t square minus 15 and compare with the standard form. What is a value? A value is 1. Here there is no b value, that is b value is 0 and c minus 15. Now alpha plus beta is equal to minus b by a. Alpha value is plus root 15 and beta value is minus root 15. That is equal to b by a means minus 0 by 1. So plus root 15, remove bracket and write here plus into minus, minus root 15. 0 by 1, 0, and this is 0. 0 equal to 0. Now coming to product of zeros, alpha beta is equal to c by a. Alpha value is plus root 15 and beta value is minus root 15. C value is minus 15 by a value is 1. Plus into minus, minus root 15 into root 15, it will be root 15 whole square. Square root will be cancelled. That is minus 15 equal to minus 15. Therefore, hence it is verified. Last problem in this main, 3x square minus x minus 4. See what you have, 3 and minus 4. Multiply. 3 4s are 12, plus and minus, minus 12. Find the factors in order to get minus 1. That is 4 3s are 12. I should get minus 1. Minus 4 plus 3 will give you minus 1. Write that 3x square minus 4x plus 3x minus 4. Among these two, is there anything common? Yes, x. 3x minus 4. Here there is nothing common. That means 1 into 3x minus 4. 3x minus 4 into x plus 1. So equate to 0 here. That is x is equal to 3x is equal to 4. X is equal to 4 by 3. Here x is equal to plus 1 if it is transforming other side, minus 1. Alpha 4 by 3, beta minus 1. Okay. Now verify the relation with the zeros and their coefficients. So that is, first take the polynomial again, 3x square minus x minus 4. Compare with the standard form, ax square plus bx plus c. Write the coefficient value. A is equal to 3, b is equal to minus 1, c is equal to minus 4. Sum of zeros, alpha plus beta is equal to minus b by a. And product of zeros, alpha beta equal to c by a. Substitute, alpha value is 4 by 3 plus beta value is minus 1. And here b value is minus of minus 1 by 3. 4 by 3 minus 1 equal to 1 by 3. Do LCM, 4 minus 3, and that is 1 by 3 equal to 1 by 3. And here product of zeros, alpha beta equal to c by a. Alpha value is 4 by 3, beta value is minus 1. C value minus 4, a value is 3. Minus 1 into 4 minus 4 by 3 equal to minus 4 by 3. Yes, with this your first main is completed. Second main, find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. So what is given here? Sum of the zeros and product of the zeros given. That means alpha plus beta value given. You need to find the quadratic polynomial. So there is a formula, do you remember? That is k into x square minus sum of zeros, that is alpha plus beta, into x plus product of zeros. Right? So they have given sum of the zeros, first question. That is 1 by 4 comma minus 1. Sum of zeros, alpha plus beta equal to 1 by 4 and alpha beta equal to minus 1. Just you substitute the values. K into x square minus alpha plus beta value is 1 by 4 into x plus of minus 1. Now remove brackets. X square minus 1 into x, x by 4 plus into minus, minus 1. And do LCM inside. That will be 4. 4x square minus x minus 4 ones are 4. Right? So now if k is equal to, what do you have here, denominator, take that value only. If k is 4, then the required polynomial is, 4x square minus x minus 4. That's it. Right? So write the formula, substitute alpha plus beta value, do LCM and get the polynomial. See the second one. Given alpha plus beta equal to root 2 and alpha beta equal to 1 by 3. Formula, k into x square minus alpha plus beta into x plus product of the zeros. That is k into x square minus root 2x plus 1 by 3. Instead of alpha plus beta and alpha beta, substitute the values. K into, now do LCM, 3 denominator, 1 you have in the denominator. So multiply 3 for the numerators here, 3x square minus 3 root 2x plus 1. Okay. Now, if k is equal to 3, then the required polynomial is 3x square minus 3 root 2x plus 1. Third problem, given alpha plus beta equal to 0 and alpha beta is equal to root 5. Now, if k into x square minus alpha plus beta into x plus alpha beta, substitute k into x square minus alpha plus beta value is 0 into x plus alpha beta value is root 5. Okay. So k into x square, 0 into anything is 0. So leave that, x square plus root 5. If k is equal to 1, then the required polynomial is x square plus root 5. See the next one, fourth one. Again same manner. K into x square minus alpha plus beta into x plus alpha beta. K into x square minus 1x plus 1. That is k into x square minus x plus 1. If k is equal to 1, then the required polynomial is x square minus x plus 1. Fifth problem, given alpha plus beta is equal to minus 1 by 4, alpha beta is equal to 1 by 4. K into x square minus alpha plus beta into x plus alpha beta. Substitute the values. K into x square minus of minus 1 by 4 into x plus alpha beta value is 1 by 4. Now remove from brackets x square minus into minus plus x by 4 plus 1 by 4. Do LCM, 4x square plus x plus 1 by 4. Right? Now if k is equal to 4, then the required polynomial is 4x square plus x plus 1. Okay. So see the last one. Given alpha plus beta is equal to 4 and alpha beta is equal to 1. What is the formula? K into x square minus alpha plus beta into x plus alpha beta. And now k into x square minus alpha plus beta value is 4x plus alpha beta value is 1. And now if k is equal to, nothing there in the denominator, so if k is equal to 1, then the required polynomial is x square minus 4x plus 1. That's it, our polynomials chapter is completed. So solve the problems carefully and please don't forget to share these videos, revision with Radhika ma'am, for your friends and make your friends also to be perfect. Right? Wish you all good luck. We are going to meet in the next video with another new chapter. Thank you all.